Hello explorers! Welcome back to Coded Universe, where we simplify programming with real-world examples. Today, we're setting off on a journey that's sure to grow your knowledge. Have you ever thought about how nature's own tree structure could be a part of the programming world? Well, buckle up, because we're about to dive into the fascinating realm of trees and programming. From understanding their structure to learning different traversal techniques, we've got an exciting adventure ahead. So, let's get started. Today, we're branching out into the world of trees and programming. Just like a family tree, programming trees have different levels of hierarchy. Imagine a tree, but instead of leaves and branches, it's filled with nodes and pointers. Each node is like a small box of information, and each pointer is a path that leads to another box. In this realm, the root stands tall at the top of the tree, overseeing all the nodes beneath it. Now, there are many types of trees in programming, but let's focus on one particular type, the binary tree. Picture a tree that only ever splits in two. Each node in a binary tree has a maximum of 2 children, aptly named the left child and the right child. It's a simple yet powerful structure. From organizing data to making efficient searches, binary trees play a significant role in computer science. So, whether you're a seasoned programmer or just starting your coding journey, it's time to branch out and explore the world of trees. A binary tree, with its twigs and branches, is a special kind of tree we often visit. Imagine a treasure hunt where you check the clue at each stop before moving on. This is what we call a pre-order traversal in the realm of binary tree programming. It's an adventurous journey that begins at the root of our tree, the starting point of our treasure hunt. It's where we unearth the first piece of our puzzle, or, in programming terms, process the root node. Now, where to next? Well, just like in our treasure hunt, we move to the left. We delve into the left subtree, exploring its nooks and crannies, processing all its nodes as we traverse. It's a fascinating voyage full of twists, turns, and data. Finally, it's time to venture to the right. We traverse the right subtree, processing its nodes and unearthing its treasures. In pre-order traversal, we visit the root, our starting point, then the left subtree, followed by the right. It's a quest of discovery, one node at a time. In-order traversal is like reading a book. Just imagine, if you will, that the binary tree in front of you is a fascinating novel. Now, how would you read it? Start from the left, move to the middle, and finally turn to the right, right? That's exactly how in-order traversal works. Let's break it down. First, we traverse the left subtree. This is like flipping open the left page of our book. We explore all that it has to offer, immersing ourselves in its content. Next, we visit the root. This is akin to reading the middle part of our book. It's the heart of our story, the central plot that binds everything together. Finally, we traverse the right subtree. It's like turning to the right page of our book. We absorb the final pieces of information, bringing our reading journey to a close. So, in essence, in-order traversal, we start with the left page, left subtree, then the middle, root, and finally the right page, right subtree. Post-order traversal is like cleaning up after a party. It's all about putting things back in order. But where do we start? Well, imagine a grand house with 3 main sections: the left wing, the main hall, and the right wing. Just like a considerate host, we first focus on the left wing, ensuring every nook and cranny is spotless. This is akin to exploring the left subtree first in post-order traversal. Next, we move to the right wing, dusting off the remnants of the celebration. This is the equivalent of visiting the right subtree. Lastly, with the wings taken care of, we turn our attention to the main hall, the heart of the party. In our binary tree, this is like visiting the root node last. It brings the whole cleanup operation, or in our case, the traversal, to a satisfying close. We tidy up the left and right rooms, subtrees, before taking care of the main hall, root. Binary trees are everywhere, from the decisions we make daily to the way we organize our files on a computer. Consider the decisions we make each day. We're constantly making choices, aren't we? Each choice branches out into different possibilities, forming a tree-like structure in our minds. This is precisely how binary trees work. Think about organizing files on your computer. You have a main folder, and within that, you have subfolders. Each subfolder might have its own set of folders. This hierarchical structure is a real-world example of a binary tree. Have you ever used a sorting algorithm? Quicksort and merge sort, 2 popular sorting algorithms, use binary trees behind the scenes. They break down the data into smaller pieces, sort them, and then merge them back together, just like traversing a binary tree. So, you see, binary trees are not just theoretical concepts. They're practical, efficient, and all around us. Binary trees play a vital role in decision-making processes and file organization. That's our stroll through the binary trees. We've hopped from root to branch, from pre-order to post-order, and discovered the fascinating world of these data structures. Just like the ecosystem in a forest, binary trees bring order and structure to the coding world. We've seen how they resemble family trees with their hierarchy and structure. We've embarked on a treasure hunt in pre-order traversal, read the intriguing book of InOrder traversal, and tidied up the party mess with post-order traversal. Binary trees are not just theoretical concepts confined to textbooks, they are practical tools that programmers use daily, from making decisions to organizing files on a computer. They are an integral part of the coding ecosystem, helping us to solve complex problems with simple, elegant solutions. But our journey in the coded universe is far from over. There are many more programming concepts to explore, many more paths to traverse. So, if you've enjoyed this journey through the binary trees, we invite you to join us on the next adventure. We welcome your thoughts and insights. Did you find binary trees as fascinating as we do? Do you have any interesting real-world examples to share? Your interaction enriches our coded universe community, and we look forward to hearing from you. If you found this journey enlightening, give us a like, drop a comment, and subscribe to Coded Universe for more programming adventures.